Hello, today's lesson is called the product law of exponents. And before we get to that, let's just talk about what a law is in math. We can also call it a property or a rule. For instance, the commutative property, if an expression has all addition or if an expression has all multiplication, the commutative property says that order doesn't matter. You could add 3 plus 4 or 4 plus 3 and get the same result. The associative property says that I can group in an expression that's all addition, or if an expression is all multiplication, I can group numbers differently and the value of the expression will stay the same. So today we're going to work with the product law, meaning we're going to multiply, and this rule or law is going to apply to exponents. We're also going to discover two other laws or rules as we go along. We're going to start with them right now. There are two special numbers that are written in exponential notation that we're going to need to be familiar with. And so 4 can also be written as 4 to the first power. Negative 12 can also be written as negative 12 to the first power. And even if we had a variable y can also be written as y to the first power. And this is known as the identity property for exponents. We've had an identity property for multiplication, meaning that if we take a number times 1, we're going to get back that number that we started with. In this case, it's 9. And that applies towards variables. 1 times x is the same thing as x. We keep the same identity. There's an identity property for addition. So if I took, let's say 8 and I added 0 to it, the identity 8 would still stay the same. It's still 8. And that would also apply to variables. If I had variable a and I added 0 to it, I'd still have a, have the same identity. So this one is just for exponents. If I raise a number to the first power, it keeps its same identity. So 4 raised to the first power would still be 4. And negative 12 raised to the first power would still be negative 12. And y to the first power would be the same thing as y. So that's known as the identity law, or the identity property. So now, this one I'm going to ask you when you get back to class and you have your calculator to prove this. And a number raised to the power of 0. Well, my brain is thinking that a number raised to the power of 0 would be 0, but as it turns out, it's 1. So I'm going to have you prove that when you get back to class and use your calculator. And the ironic thing about these two properties is if I see 4 and I don't see an exponent, our natural inclination is to want to put a 0 here, but that's not what we need to do. It's to the first power. So this also works if I put 25 and raise it to a 0 power. I'm still going to get back 1. So when you come to class, prove this. If it's a negative number, negative 8, if you recall last lesson we talked about that we have to enclose, we have to kind of marry that negative sign to the number. That's still going to be 1. And in our next example, you're going to notice we have parentheses around a fraction. We have to do that. We kind of marry the numerator and the denominator. Otherwise, this 0 would look like it's just attached to the 1 and not to the 2. But again, if we raise a fraction to the 0 power, it would be 1. And since I have a variable, I could fill this in with any number. So if I filled it in with any number, a variable raised to 0 power is still going to be 1. So we're going to need both of those laws, and this is known as the 0 property. So we've talked about this one, so we're going to call this the 0 property, and we'll fill in our little chart after this lesson. Today, we will simplify the product of two or more expressions given in exponential form into one expression. So just to recall, we've done something similar to this in the past when we're combining like terms. For instance, if I had 5x and I added 3x, those are two like terms, and so I could simplify these and make this into one term, 8x. So this is kind of a very similar concept. So we're going to start, so we can prove how we're going to write exponential form. We're going to start by writing each expression in factored form, also known as an expanded form. So we practiced this the other day, and if we look at this first number in exponential form, 6 to the third power means 6 times 6 times 6. And then we see another multiplication sign, and now we have the second expression is 6 to the fourth power. So that'd be 6 times 6 times 6 times 6. So this is the expanded form way. And this is the first expression, 6 to the third power. This is the second expression, 6 to the fourth power. But if you notice, since they're all 6, they all have the same base of 6, we can write this as 6 to the 1, 2, 3, 4, 5, 6, 7th power. So now let's try the next one. We see 7 to the third power. So that would be 7 times 7 times 7. We see this times dot, and then we see times another 7. So here's the first expression, second expression, and we can write this as 7 to the fourth power. Letter C, now we have a negative number, so we're going to write negative 5. It's raised to the third power, so negative 5 and negative 5. So there's 3 of them. Then a times dot, and then we have negative 5 and negative 5. And I could write the times dot, but I'm letting the parentheses do that work. So what I see visually is negative 5, and I see it 1, 2, 3, 4, 5 times. So negative 5 to the fifth power. And remember, we have to enclose negative bases and parentheses. And our last example is 3 to the second power. So 3 times 3 times dot, and then 3, and then times dot, and then 3 to the fourth power. So 3 times 3 times 3 times 3. So we have 3 to the second, 3, and 3 to the fourth. But all together in exponential form, that's the same base, they're all 3's, and that is to the 7th power. So do you see a pattern when you compare the original expressions to the exponential form? Could we go from here, could we start with the original to here without having to expand it? Are you noticing, or can you think of a rule or shortcut instead of having to expand it each time? Well, hopefully you noticed that if I have 6 to the third power and 6 to the fourth power, if I add those exponents, let's try this, 6 to the third power plus 6 to the fourth power, I get 6 to the 7th power. This next example, I have 7 to the third power, but if you recall, we just talked about if it doesn't have an exponent, that's raised to the power of 1. So that'd be 7 to the first power. So altogether, when we add them, that's 7 to the fourth power. When we had a base of negative 5, we had negative 5 to the third power and negative 5 to the second power. So when I add them, yep, that again is the same exponent, negative 5 to the fifth power. And the last one, even though they give us 3 separate exponential form numbers, 3 to the second power, again 3, we could put first power, so that's plus 1, and 3 to the fourth power, these are all the exponents. If we added all those exponents, we'd get 7. So that is the product law for for exponents. And what it says is if we have the same base and they're raised to a power, we can add those powers if it's being multiplied. Product means multiplying. So turn to the next page. So we're going to write the official law or property of exponents for multiplication, also known as the product law. So when you hear the word product, it is the end result of multiplication. So it says let x represent the base and let n and m represent the exponents. So here's the official law of exponents. If we have x and we raise it to the nth power, so those would be numbers, but we're writing it as variables, and then we multiply that same base x to a different power, which we're going to call m, then the rule says we keep that same base, which we're calling x, but we add the exponents. So in the past, I've told my students that if they see multiplication, and this is kind of a mind bender, if we see multiplication, we add the exponents. So when you see multiplication, add. And that's kind of a weird rule. So we're going to try these. I'm going to have you try some on your own. We're going to keep the base, and we can only use this as long as we have the same base. So the base, both of these expressions have the base of 15. We're going to take the exponents, and we're going to add them. So we have 7 plus 2, so we're using this law, and then we want to finish it up by writing it in simplest form, which would be 15 to the 9th power. So using that, would you please continue? Would you try using the product law? Please show this step and then the final simplified version of it. And after you're done, please replay this video and check your answers. Okay, this is what you should have gotten, and I want to briefly talk about this. I kind of glossed over it on the first page. If I didn't include parentheses on this and I wrote it like this, then you might think that this exponent is just on the 2. So that's why we enclose fractions in parentheses, because if this, the way they have it written here, looks like 2 times 2 times 2 times 2 times 2 times 2 all over 3, when we really want 2/3 times 2/3 times 2/3, etc. So let's look at the very bottom, and then we're almost finished with this. We can also write these expressions without showing the multiplication sign, which would be the high school way. And if we recall, side by side means multiply. And we can write it with negative exponents. So let's try J and let's try M together. So once again, we can use this law of exponents because side by side means multiply. If I see multiplication, I have the same base, I add the exponent. So the final answer will be 3 to the 12th power. And letter M, well now we have to deal with negative. As long as these bases are both the same, side by side means multiply, so I'm going to use this law. As long as they're both the same, I'm allowed to use this law. So I'm going to put N, that's the same base, and the law says I'm going to add the exponent. So negative 8 plus 3 would be negative 5. So the final answer would be n to the negative 5th power. So this is our simplified version. So would you please do K and L and then replay the video? All right, and just to recall, if we're not given an exponent, we use a 1, not a 0. So this should be an x to the 8th, final answer. And when we add two negatives, if you recall, it stays negative. And so this should be 11 to the negative 9th power. Thanks for listening. Have a great day. We'll continue this lesson tomorrow.